Warm welcome to everyone. This is Prathima Kadari, a regional ambassador of Hackmakers for Build with AI Hackathon. Today I had come up with most prominent topic titled Demystifying Machine Learning to Develop Smarter Solutions, wherein we would explore all the implicit needs one requires to know before working on real-time machine learning solutions. Now let's come to our topic outline. Coming to our agenda, we will scratch up the surface of machine learning along with important terminologies, stages of ML, boosters you can apply, tips and insights on how to improve model accuracies, and adding some smartness to your ML solutions. Now let's get started with knowing what is actually machine learning. Machine learning is a subset of artificial intelligence. Machine learning is a set of algorithms and statistical analysis that allows the creation of ML models that computers use to learn without any programming or instructions on learning process. It actually helps data scientists analyze data and create predictive or descriptive models to solve a particular task or a problem. The main goal of ML is to automate the learning process for computers and eliminate human intervention. Coming to the importance of machine learning, it's mainly responsible for accessing the importance of data and helping algorithms in gaining knowledge from data sets. Machine learning actually comprises of three parts: the computational algorithm at the goal of making determinations, variables and features that makes up the decision, knowledge that trains the system to learn. Why it's used? It's because the data-driven decisions makes the difference between keeping up with the competition or falling behind. It's a key factor to unlock the value of corporate and customer data and enacting decisions that keeps the firm ahead. Now let's explore more of machine learning. It's more or less finding patterns in the data and a form of replacing code with supplying data. Here, the system tries to figure out what this person needs based on examples. There is a need to abstract from training to test examples. It can be categorized in various ways, like unsupervised learning, supervised learning, semi-supervised learning, and reinforcement learning. Supervised learning algorithms use labeled data, and unsupervised learning algorithms find patterns in unlabeled data. Semi-supervised learning uses a mixture of labeled and unlabeled data. Reinforcement learning is a way to train algorithms to maximize rewards based on feedback. Currently, let's focus on supervised and unsupervised learning. In supervised learning, a human resembles as a teacher that enriches the training data with expected output. The computer learns the patterns based on the output that showcases. This type of training data is called as labeled data and produces a predictive model. Coming to the points that comes under supervised learning is regression and classification. Regression is used when there is a necessity to predict a specific number or something. Classification. To be honest, it's a form of classification to predict whether something is one form or another with true or false statements. If there are two classes, it's called as binary classification, and more than two as multi-class classification. Now coming to unsupervised learning, here a computer learns from unlabeled data. This approach is mainly used to find patterns in data and discover new meaningful insights. We have various methods like clustering, anomaly detection, and recommendation. Splitting the dataset into groups based on similarity is termed as clustering. Identifying unusual data points in a dataset is called anomaly detection. Recommendation is a way of recommending something to someone, such as buying products based on their previous purchases or articles to read based on their reading history. Now coming to the 6 stages of machine learning. We have 6 stages of machine learning, such as data collection, data preparation, train a model, analysis or evaluation, serve model, or recreate model. Before data collection, first we need to see if the data exists. If it exists, where can the data is available, if it's public or private. Also make sure if it's structured or unstructured. There are many ways to depict it. For structured data, it appears in a tabular format, like an Excel spreadsheet. It contains different types of data, for example, numerical, categorical, time series. Before working on data, you need to ask few questions so that you get a pure clarity on how to proceed further. Along with that, we should also know exploratory data analysis is a way of what data you are working with and how it can learn out of the data analysis. Now coming to unstructured data, we have various other data which has no labels, which are hard to predict, but it helps in getting insights from the machine as it tries to find patterns in the unlabeled data. Now coming to data preparation. Data preparation is like a pre-processing statement where data is prepared before getting into a model condition. Yes, so here what we look for is, here we use exploratory data analysis to see and analyze the data on how it can be used or make it get ready for the model to be prepared. It preprocesses the data and splits the data according to the needs. So along with that, we also can see we have to go to various options. Data splitting actually happens with usually 70 to 80% of data into training or 30 to 20% into testing. That's a way of validation. Training a model. Training a model is a most important aspect on these stages of machine learning. We choose an algorithm, overfit the model, and reduce the overfitting with regularization. Choosing the algorithm is the most aspect before getting to choose on how model can work on that particular conditions. For supervised algorithms, we have various algorithms like linear regression, logistic regression, k-nearest neighbor, decision tree, random forest, adder boost, and so on. For unsupervised learnings, we have clustering, dimensionality reduction, principal component analysis, and anomaly detection. Coming to our picture, you can see you can choose an algorithm based on your problem or detail. Yes, it's based on a data or problem you have got from the statement. Overfit, then regularize. It's better you do an overfitting before regularizing. Now let's look into how to use hyperparameters. This is also the most important reason to make efficient models that works for the optimal solutions. You will be seeing about it in future slides. It's a continuous process of machine learning lifecycle. Now next process is about analyzing or evaluation. Here, things are analyzed and evaluated based on the metrics. For example, in case of classification, you can use accuracies, precision, recall, F1, confusion matrix, or various other factors. For regression, we have mean square error or mean kind of errors that very much applicable to be used in these conditions. Along with that, we also have a task-based methods that's mostly used on self-driving cars. Now coming to the diagram, here we can see the first process is of evaluating the metrics, then future importance on to check the factors and values that should gain large importance and be clear, clear confirmation of how it can be used. Along with that, we also see with the training inference. That's the main thing because it can lead to the first examples. Next process is serving the model. When you're serving the model, it means a deployment of model. Before you put the model into use and see how it goes, you need to check on how it can work or how the condition appears to be happening before getting into the production or use purpose as an output result. So for that, we can see here, we have various kinds of processes to do before checking out with the serving and deploying the model. Once you put your model into deployment, you have to see and evaluate is as if it's performing according to your needs. If it is not, then push it to evaluation metrics and also do change the metrics according to the needs so that the model performs better when it's deployed. Coming to our last stage of machine learning lifecycle, it's a retraining a model. We have to ensure always model performs best before getting to production learning. So it's better to see based on the evaluation methods and revisit the above steps if it's not appropriate as required. Machine learning is quite experimental, so you need to keep a tracking of your data and performing experiments to make it perform better. Coming to our next slide, you would like to answer or you would like to know what are ML boosters? That's are most prior and important if you're working on ML problem statements. At times, your ML might get stuck in accuracy. Your model might get stuck in accuracy. This leads with an easier suggestion of adding more data. But what if you couldn't find any more data or didn't work as expected, even when data has been included? This is when ML boosters comes to your rescue. Yes, you heard it right. For hyperparameter tuning, it's a method through which we can control user settings of ML model. It also helps in influencing how models parameters will update and learn during training. The model's output depends on its learned parameters that updates constantly on training phase. When hyperparameters are set right, the model will learn most optimal that it possibly can with trained data and algorithm. It's kind of trial and error with estimations. Next comes the topic of assembly methods. It's the most prominent technique of combining multiple model predictions at once. The basic idea behind it is to add knowledge of all these models to get more accurate result than looking out of only single one. It's an intuitive technique followed. The workflow is to simply train multiple ML models using same data and apply all the models to input individually. Like if it's regression, results can be averaged, and for classification, you can join the results using any class or take predictions that has highest confidence. It's a real-world proven technique to boost prediction accuracy. Coming to future engineering involves the careful selection and possible manipulation of your data features. The purpose of this is to feed your model with only the most optimal form of input. If you can consistently give your model only the parts of the data it needs to make accurate predictions, then it doesn't have to deal with extra noise that comes from the rest of the data. If you notice some features of data may not be necessary to understand the training phase, such as ID or date, else if you need a customized feature that needs to be considered for the prediction. Do some data exploration to know what information and future plays a key role for your predictions to give best data of your model. There might be some features which doesn't add value to your solutions. Here are the ML boosters which can help you in improving your model accuracy. But if you want to play tactical in your problem statements, here are the go-to ones. Future selection is a process of finding out the best subset of attributes that explains the relationship of independent variables with target variables. Resourceful futures that can be characterized based on various metrics. Coming to domain knowledge, futures are selected based on higher impact it has on target variable. And next point is visualization. This helps in visualizing the relationship between variables that makes your variable selection process easier. Other important topic is cross-validation. We have seen the boosters that can help in improving accuracy, but sometimes models which have high accuracy cannot perform better due to overfitting. Here comes the term cross-validation. It's the most viable concept in data modeling. That suggests to leave a sample on which you do not train the model and test the model on this sample before finalizing with it. Let's get to our next slide. We will know more other important features that can help you in improving your model accuracy. Adding more data samples. Yes, data flows like a story only if it's enough to process. Data samples add some input and perspective that's trying to share it to you. This being said, the easiest way to do so is by adding more of data to training. Existence of more data would result in reliable and accurate models, as that's how machine learns. With missing and outlier values. It happens when there is an unwanted presence of missing and outlier values that exist in training data, which might tamper your efforts in gaining good accuracy of your model and might tend to get biased or with inaccurate predictions. It's because behavior and relationship with other variables aren't analyzed correctly. So values should be treated well on prior stamps before the data training and model creation. In missing values, we can use continuous variables which can be imputed with mean, median, and mode. And for categorical variables, the variables can be treated as a separate class. For outliers, the values can be treated separately by deleting the observations, else can be performed using transformation, bringing, or imputation. Now we have to look at the problem differently. Yes, when adding more data doesn't work in case of model accuracy, then looking at a problem in a new perspective might add some resourceful information to your model and lets you uncover buried relationships between variables. Asking queries to yourself may lead to better results. Next is add some context to your data. Context is always necessary in any aspect of situation. And training an ML model is no different. Just one point of data won't be able to express a story. For this, an extra content should be added for any algorithm we plan to apply for this data to gain good performance. This would fetch with wide understanding of the problem statement and gets better eventually. As discussed earlier, other important and prominent thing to know in developing or making your solution smarter is fine-tuning parameter. That's a hyperparameter. There are certain rules to be followed to train a model, as this can only help you get answer. But to get it, some trial and error should be done. The way to optimize it is use its hyperparameters that might lead to better accuracy and performance. Train your model using cross-validation. It's a technique used to enhance the model training process by dividing the overall training set into smaller chunks and then use each chunk to train the model. Using this approach, we can enhance the algorithm's training process by training it using different chunks and averaging over the result. It optimizes the model performance and its approach is popularly used as it's widely and easier to implement. Coming to experimenting with depth algorithms, if we have tried out all the approaches and still lagging behind in terms of accuracy, clearly states that the algorithm you are trying to implement doesn't rightly match with your data we have, and it results not getting performance as expected. Instead, you can change your previous algorithms to see how performance impacts the implementation and gets you exposed with lots of details about data and story it's trying to express. Coming to our last slide, we will be knowing a way to add some smartness to your ML solutions. Comprehensive design data strategy. A successful machine learning solutions are performed. It started with a strong data strategy. The machine learning model is only as good as data it gets trained on, as it's the main challenge. If there are problems with data, this would end up spending their time doing data cleanup and management, as they don't have the data that they require. Data is put to work through analytics and machine learning to make better decisions, create efficiencies, and drive new innovations. We should carefully select ML use cases and set success metrics. It should start with problems that needs focus, seeing which ones could be solved with machine learning, and outline clear metrics to measure success. Things to keep in mind include data. That's mostly prior and important while working on this kind of situations. Understanding of equations. Equation is one of the topics of successful ML project and is vital on many levels. It's important to accept that your first model will not be accurate or precise. Machine learning is experimental, so starting small and iterating towards your goal will lead to higher value predictions in the long run. Iterating provides confidence at every stage as you eliminate factors that degrade the quality of your model performance and progressively make more informed decisions with respect to data that you put input in your model. Storing the model code, hyperparameters, and result metrics of every experiment and tracking the changes in variables and data is an essential part of the process. Because you must be available to discuss results, find the root cause of issues, and reproduce experiments and decipher where issue occurs. Focusing on quality data is again an important aspect. Data preparation is the most unique and important step in creating an ML project. The final predictions will ultimately depend on the quality of the initial input data. So the first step is crucial. Preliminary data analysis allows not only to understand any trends that they might see once the prediction starts, but will also help you visualize how class balanced your data set is, whether or not it has missing values that will generate bias, or if there are any outliers in the data that may influence predictions. Distinct patterns and potential causation in your data will lead to more accurate outputs from your model. Keeping an eye on models is also again a key factor. Once ML models are put into use and actively making prediction, reciprocity is needed. It is important to monitor. It can completely change outputs. So keep track of how accurate and precise your models are is essential while developing or while deploying a project. and that will not become overrun with data when rendering the model is useless. Valid time should be invested in exploring how it's performing and ways it can be improved. Model monitoring is to make sure or ensure that the model is working as per the expectations. The model is providing predictions accurately and fairly in all scenarios. It also helps detect the scope for quick improvements and enhancements of the model. So keep track of your model's performance to avoid any problems doing the road. We have at times we feel the solution isn't as efficient as possible. This is where you need to check on if there are any loops left out. Ask a question to yourself. Is this justifiable enough to be called a good strategy solution? This is where you have to see on how to fill the gap that has to be acknowledged. Now comes the last and again a final topic. One is one of the most important steps. Is to check on vehicle scalability before using it, and it should be able to handle large volumes of data according to demands instead of rebuilding the models again. Ensuring that your pipeline is scalable in every way is essential for a successful project. Thank you, Hackmakers, for providing this opportunity to present my topic. Hope everyone understood with all the insights and strategy you might need to know while developing smarter solutions using ML. Thank you for this time. Thank you.